Hello and welcome to Cannon County High School Algebra 2. Today we're going to be talking about some special right triangles. And if you had geometry last year, and I know some of you did and some of you didn't, but if you had geometry last year, a lot of this might be review, but it's going to be important that you understand it so that you can understand what we're going to be doing next. Those of you who haven't had geometry, this is all going to be new, I'm sure. So let's get right to it. So Mr. Lyon, you're going to have to go over here and watch again. Sorry about that. I'm sure, even if you didn't have geometry last year, remember what this is, the Pythagorean theorem. The Pythagorean theorem just says that c squared is equal to a squared plus b squared, where c is the longest side of a right triangle, the hypotenuse, and a and b are the legs of that right triangle. We're going to be using that today, but we're going to be making some special triangles where you don't necessarily need to know 2 out of the 3 sides. With the Pythagorean theorem, you always need to know 2 of the 3 sides to figure out the 3rd side. With the special triangles that we're going to make today, you don't need that. You only need to know 1 of the sides. Okay? So let's take a look at one of those special triangles. We're going to start out with an equilateral triangle, and what we're going to do is draw an altitude of that. And you know that the altitude is a line that just goes straight down the middle like that. It's at a right angle. And because it's an equilateral triangle, you know that this angle is how many degrees? That's right, 60. 60 degrees, because you know that there are 180 degrees in an equilateral triangle. And if it's equilateral, it's also equiangular. And what that means is they're all the same. So that means 180 divided by 3 is 60. So this angle is 60, this angle is 60, and this angle up here is 60. Now, since this is an equilateral triangle and we drop this straight down the middle, that means this little angle up here is how much? That's right, it's 30. So you've got a 30-degree angle there, a 60-degree angle there. And now if this whole distance is 2, then how far is it from there to there? Exactly, it's 1. And what we've made then is a triangle that starts out, if I just draw the half of the triangle, like this is, well, what would that be for the Pythagorean theorem? That's the side opposite the right angle, the longest side of this right triangle, so that's the hypotenuse. This is the shorter leg, that's 1 unit long. And then we can use the Pythagorean theorem to figure out what the other one is. So you already know that a squared plus b squared, let's call this side x. That's the longer of the 2 legs. There's a short leg and a long leg. This angle is 30 degrees, this angle is 60 degrees. So that means that 2 squared has to equal 1 squared plus x squared. And now if we solve this for x, we would get 4 equals 1 plus x squared. Subtract the 1 from both sides, you get 3. And take the square root, and you get the square root of 3. So x is going to equal the square root of 3. Now I know what you're saying. You're saying, but Mr. Fowler, you told us before when you take the square root, you get a plus and a minus. And that's true. But in this case, it's a distance, and a distance is always positive. So this is a special triangle. If you remember this ratio, 1 to 2 to the square root of 3, well then you can solve any 30, 60, 90 triangle using these ratios. So keep that in your memory for just a second, and let's talk about a different one. We'll come back to that one. All right, we got a square this time. Draw the diagonal of a square. And let's say that this square has, each side is 1 unit long. Now, you know a square has right angles. And since a square is the same on all, you know this is also a right angle, so what would this angle be? That's right, 45. That angle's 45 degrees, and that angle's 45 degrees. So, just like we did with the other one, I'm going to take this triangle and drop it down here with my artistic ability. Not so good, I understand. But that's 1 and that's 1. We want to figure out what this side is. And just like before, we're going to use the Pythagorean theorem. So this time we're trying to find the hypotenuse. So that means x squared which is like c squared, is going to equal 1 squared plus 1 squared. Well, 1 squared and 1 squared, that's 1 plus 1 is 2. So x squared is equal to 2. And when you take the square root of x, you get the square root of 2. So x is the square root of 2. So this is what we call a 45, 45, 90 triangle. And this is the ratio that we're going to use. And what I've done, these two special triangles, I've made a little cheat sheet that I'm going to use for our assignment. These are the ratios, and I put an X next to each one of them because if you have a 30, 60, 90 triangle or a 45, 45, 90 triangle, it doesn't matter what size the sides are, they're always going to be in these ratios that we discovered earlier. So let's try a couple of these, and I'm going to leave our cheat sheet here so that we can use it to come up with some answers. Here is, let's say you're doing the IXL that I'm going to ask you to do in a little bit. And here is a 30, 60, 90 triangle. Now this only says 30 degrees here, but if this is 90 and this is 30, then you already know that this is going to be 60. It doesn't even necessarily have to say it there. So choose your triangle. Obviously we're using this one this time. Then you want to figure out, in this case, they're giving us the longer of the two legs. They don't really care about the hypotenuse on this one, but they're asking us to find the shorter of the two legs. If you look at the reference triangle for a 30, 60, 90, which of these three is the longer of the two legs? Right, it's this one right here. It's the one across from the 60-degree angle. Remember, the longer of the legs will be opposite the 60-degree angle. The shorter of the legs will be opposite the 30-degree angle. So they're giving us the longer leg, and they want us to find the shorter leg. So you just have to ask yourself, how does one go from x times the square root of 3 to just x? Well, you would have to divide by the square root of 3, because this one has the square root of 3. The only way we could get rid of that is if we divided by it. So to go from here to here, you divide by the square root of 3. So to figure out this, we're going to take 7 times the square root of 3 and divide by the square root of 3. And what happens is the square root of 3 will cancel out, and you get 7. And so the answer is just 7. These reference triangles make it very quick and easy to solve for missing sides of these triangles without having to go through the entire Pythagorean theorem. Let's try another one. Okay, choose your reference triangle. All right, this time we're using our 45, 45, 90. Now ask yourself, well, on a 45, 45, 90, there is no long and short leg. There's just two legs that are the same. And this time they've given us one of the legs, and they're asking us to find the hypotenuse because the hypotenuse is opposite the right angle. So go to your reference triangle and just ask yourself, what do I have to do to one of the legs to get the hypotenuse? Well, to go from x to x times the square root of 2, you have to multiply by the square root of 2. So c is just going to be 7 times the square root of 2. Done. How about this one? Choose your reference triangle. All right, this time again, we're using a 30, 60, 90. What have they given you? They've given you the hypotenuse. The hypotenuse is opposite the right angle, and they want you to find which side, the short side or the long side. Or I should call it short leg. You have a short leg and a long leg. They're trying to find the short leg, D. So look at your reference triangle and say they've given me 2x. I want to find x. How do you go from 2x to x? You divide by 2. So do the same thing here. 6 divided by 2, 3. Is this easy? Yeah, that's the whole point. Once you understand it, it is easy, and that's the whole point. You want to be able to do these quickly and easily without doing all the work of the Pythagorean theorem. These two triangles show up a lot in trigonometry, and that's why it's good to know them. I'm giving you this reference card right now, but eventually you'll have these memorized. It won't be something you even need to write down like I've done here. How about this one? Oh, I didn't write down what kind of triangle that is. That's a 30, 60, 90 triangle. And just ask yourself, what is given? What did they give me here? Well, they gave me the hypotenuse. And what do they want? They want the longer of the two legs. Well, this one Well, let me tell you, this is the one that is a little bit tougher because it's very difficult to go from the hypotenuse. What do you have to do to 2x to get x times the square root of 3? Well, you can, but it's not super easy. I really wish they would have asked me to find the shorter leg, because then I could just divide by 2. If I knew the shorter leg, it would be really easy to find the longer leg, because then I would just multiply by the square root of 3. So that's the key to doing these kind of problems. The short leg is always the key when you're trying to go from the hypotenuse to the longer leg or from the long leg to the hypotenuse. First figure out this, and that will make it easier to find the other one. What do you have to do to go from the hypotenuse to the shorter leg? From the hypotenuse to the shorter leg, you divide by 2. So what's 6 square roots of 2 divided by 2? It's 3 times the square root of 2. Well, now that we know the shorter leg, now it's easy to find the longer leg. Because to find the longer leg, you just take whatever you have for the short leg and multiply by the square root of 3. So if the shorter leg is 3 square roots of 2, we're going to multiply that by the square root of 3. And what is 3 times the square root of 2 times the square root of 3? Well, that's just 3 times the square root of what? That's right, 6. And there you go. So that one was a little tougher. But remember, if you're given a 30, 60, 90 triangle, it's always good to find the short leg, even if that's not what they're asking for, because that will help you to find the other ones. All right, let's try this one. Pick your reference triangle. 45, 45, 90. What have they given you? They've given you a leg. How do you find the hypotenuse if you're given a leg? Well, look at the reference triangle. If you know the leg is x, how do you find the hypotenuse? How do you go from here to here? You multiply by the square root of 2. So what is 2 square roots of 3 times the square root of 2? That's 2 times the square root of 6. And there it is. Okay? Not so bad. Let me try another one. Can they get harder? Well, there might be a little bit of algebra you have to do once in a while. We'll see if we get one of those. This is a 30, 60, 90. They're asking for, they've given us the short leg and they want the hypotenuse. Short leg to hypotenuse. What do you think? Short leg to hypotenuse. You have to multiply by 2. What's 5 times 2? 10. Boom, quick, easy. That's the whole point. How about this one? 30, 60, 90. They've given us the long leg and they want us to find the hypotenuse. They've given us the long leg and they want us to find the hypotenuse. Well, again, that's not as easy. Remember, I just said the key to these kind of problems is figuring out what the short leg is first. So forget about A for a minute. Let's just go from here to here. What do you have to do to this to get this? What do you have to do to x times the square root of 3 to get just plain old x? You have to divide by the square root of 3. So let's figure out what that is. What is 4 times the square root of 3 divided by the square root of 3? Well, it's just 4. So that means that side is 4. Now that you know that side is 4, it's very easy to figure out the hypotenuse. If I know that this is x, I want to find the hypotenuse, so I multiply by 2. So 4 times 2 is 8. All right. We'll find a difficult one yet, I promise. Let's try this one. We know that this is 3, that's the long leg of the 30, 60, 90, and we're trying to find the short leg. Well, to go from the long leg to the short leg, you divide by the square root of 3. That's right. So we're going to take 3 and divide it by the square root of 3. And that is the right answer. But there's something wrong with that answer. And when you're doing the IXL for this, it will say you have to put this in what's called simplest radical form. And you probably remember from Algebra 1 and Algebra 2 that simple radical form means really 2 things. You can't have any perfect squares inside the radical, which there isn't. 3 is not a perfect square, but you can't have any radicals in the denominator either. And we do have that problem. So what we're going to do is we're going to multiply this by 1, because that won't change what it's equal to, but it will change what it looks like. The form of 1 that we're going to multiply by will get rid of the square root of 3. Can you think of what that is? Aha, that's right. It's the square root of 3 divided by the square root of 3. That's really 1, right? Square root of 3 divided by the square root of 3 is 1. So 3 times the square root of 3 is 3 times the square root of 3. The square root of 3 times the square root of 3 is just plain old 3. And those will cancel out, and you get the square root of 3 for your answer. That's in simple radical form. If you were to type this into your calculator or this into your calculator, you would get the same decimal. But on IXL, they always want the answer to be written in simplest radical form. Okay? All right, last one, I promise. 45, 45, 90 triangle. So here's our reference. We're going to go from the hypotenuse to the leg. So how do you do that? You divide by the square root of 2. So you take 3 divided by the square root of 2. Do you see the problem again? It's the same problem we had on the previous one. So we're going to multiply again by a form of 1 that gets rid of that square root of 2 in the denominator. Last time it was the square root of 3, this time it's the square root of 2. So we're going to multiply by that and get 3 times the square root of 2 divided by 2. Now this 2 will not cancel out with that 2. And so the answer just looks like that. And that's it. These are special right triangles that will make life easier for you when you get to some more complicated things later on in Algebra 2. So make yourself a little cheat sheet the way I did. Take a little piece of paper and draw these 2 reference triangles on it. And then go to IXL Y.2, and that is your suggested practice for the day. Go to Y.2 on the IXL, and that's where I took these problems, and that would be a good lesson for you. Thanks for watching. We'll see you tomorrow.